Hello mathletes, welcome back to my channel, and this time we're going to continue our discussion on um, evaluating limit of a function using tabular and graphical approaches. And to further analyze the idea presented about the limit of the given function f of x equals x squared plus x minus 6 all over x minus 2 as x approaches 2. Let us illustrate the graph of f as shown in this figure. Um, the graph of this function actually was sketched using a graphing tool, GeoGebra. It is a free software designed to sketch graphs of different functions or equations, and you may download this at Google Play. Going back, so observe that the graph of f is a straight line defined at every real number x except at 2. So that means f of x is not defined at x equals 2. Since if x equals 2, then f of x will be equal to 0 over 0, which is undefined. And in the language of calculus, it is called indeterminate. And we will discuss separately topics about indeterminate. But for now, let us observe what happens to the values of f as x approaches 2 from both sides. And to do that, let us first look at the left side of 2 using values sufficiently close to 2. In the figure, we can see that the values of f, as we use values of x within 1 to 2 here, but of course not necessarily equal to 2. Notice that the value of f begins with 4 as x begins with 1. Since initially we set 1 as our first value of x. So when x is equal to 1, that means x is equal to 4. And as x approaches 2 here from the left, that means f approaches 5. Okay? And this time, let us consider the right side of 2. In the same figure, we can see that the values of f, as we use values of x within this time within 3 to 2 here. Again, not necessarily equal to 2. Here, the value of f begins with 6, since initially we begin with 3. So when x is equal to 3, our value of y is equal to 6. And the value of y approaches 5 from the right as x approaches 2 from the right. Okay? So graphically, or in this graphical approach, we can find that the limit of x squared plus x minus 6 all over x minus 2 as x approaches 2 is 5. Okay, so generally in analyzing a graph to evaluate the limit of a function as x approaches a number c, in this case x approaches 2 from the left of 2. So to do that, we must trace the part of the graph immediately on the left side of x equals 2 towards 2. Let me show it to you. Again, so using graphical approach, what we are going to do is to trace the part of the graph immediately on the left side of x equals c. So we have to take note that x equals c and the value of c here is equal to 2. So trace the part of the graph immediately on the left side of 2. So if we're going to trace the graph from the left side of 2, so we have here this one, so that means it's approaching this point where the value of y is approaching 5. On the other hand, to evaluate the limit of a function graphically as well, as x approaches the graph or the number c or 2 from the right of 2, we must trace the part of the graph immediately on the right side of x equals 2 towards 2. So starting from the right side, so trace the graph towards 2 from the right. So we have here, let's denote this using different color. Okay, so from the right towards 2. Okay, so it's also approaching this point where the value of our y coordinate approaches 5 as well. Okay, so that means, so from both sides, graphically, the limit of a function approaches a number 5 from the left and from the right. Alright, so with the use of the tabular and graphical approaches to understand and evaluate the limit of a function, we can now formally give the definition of the limit of f of x as x approaches the number c. Okay, so let us define the limit of a function. The limit of f of x as x approaches c is equal to L, provided that we can make the number f of x as close to L by choosing x sufficiently near, though not equal to the number c. In symbols, we have this one, which is read as the limit of f of x as x approaches c is L. For better understanding, let us consider the following example. In this example, use the tabular and graphical approaches to evaluate limit of x squared minus 6x plus 11 as x approaches 4. So if you recall, using the tabular approach, we need to make a column for our x and another column for our f of x. Then, so let us recall the concept of the number line. So x approaches 4. That means the number closest to 4 from the left is 3, and the number closest to 4 from the right is 5. So from the left, we're going to choose values for x greater than or equal to 3, but less than 4. And this means we're going to choose 3, 3.5, in between 3 and 4, 3.5, 3.6, 3.7, or we can automatically proceed to 3.9, which is almost equal to 4, or 3.99, or we can add more digit, 3.995 or 3.999, just like what we did from our previous examples. And from the right side, x is this time x is less than 5, less than or equal to 5, but greater than 4. So that means we're going to assign values in between 4 and 5 from the right. So initially we have 5, and then we can choose 5.5 or 5.6, 5.7, or we could have 5, I'm sorry, 5, and then from the right, so from the right, that means it's going lesser and lesser. So we could have 4.5, or 4.4, 4.3, 4.2, or 4.01, 4.001, or 4.0001. So it depends on you. That's it. So let's start. Again, we have here x, and we have f of x. So if x is equal to 3, let's solve. So the function actually is x squared minus 6x plus 11. So that means when x is equal to 3, 3 squared minus 6 times 3 plus 11. So we have here 3 squared is equal to 9, minus 6 times 3 is equal to 18, plus 11. Then 9 minus 18 is equal to negative 9, plus 11, which is equal to positive 2. So when x is equal to 3, our f of 3 is equal to 2. Okay. And let's say our next value is equal to let's erase this first. is equal to 3.5. Okay, so if x is equal to 3.5, so we have here 3.5 squared minus 6 times 3.5 plus 11. Okay, so in this case, to make our computation a little bit faster, you can use your calculator. Okay, so we have 3.5 squared, 3.5 times 3.5, that is 12.25, and then minus 6 times 3.5, which is equal to 21 plus 11. And simplifying further, we have 12.25 minus 21 is negative 8.75 plus 11. So negative 8.75 plus 11 is equal to, I will write the answer directly, 2.25. Okay, then let's choose another value much closer than 3.5. So this time, let us choose 3.9. Okay, so when x is equal to 3.9 squared minus 6 times 3.9 plus 11. So 3.9 squared, that means 3.9 times 3.9 if you are using an ordinary calculator. But if you are a scientific calculator, you can actually directly squared 3.9. So 3.9 is equal to 15.21 minus 6 times 3.9, which is equal to 23.4 plus 11. So 15.21 minus 23.4 is negative 18.19 plus 11, and negative 8.19 plus 11 is equal to 2.81. Okay, 2.81. Then next, let us choose another value much closer to 4 from the left. So we have 3.9. This time, let's add another one digit on the right hand side rather. So we have 3.99. Okay, so substitute. So 3.99 squared minus 6 times 3.99 plus 11, and 3.99 squared is equal to 15.9201 minus 6 times 3.99. So 6 times 3.99 is equal to 23.94 plus 11. Then simplifying, we have 15.9201 minus 23.94 is equal to negative 8.0199 plus 11. So simplifying further, we have negative 8.0199 plus 11 is equal to 2.9801. Okay. You might ask, how many values for x are we supposed to use or assign for x to find the possible value f of x approaches to? Well, it depends. Usually it will be indicated in the problem if at least five values or 5 numbers. Okay, but if it's not indicated, well, it depends on us or on you. How many numbers are you going to assign to x to observe what value f of x approaches to? Okay, as long as you can observe what value f of x is approaching as it gets closer and closer to that value c. And let's assign another number. This time 3.999. So 3 nines. So I think this will be the last one. Okay. So when x is equal to 3.999 squared minus 6 times 3.999 plus 11 is equal to, so 3.999 squared is simply equal to 15.992001 minus 6 times 3.999 is equal to 23.994 plus 11. And simplify, we have 15.992001 minus 23.994 is equal to negative 8.001999 plus 11. Simplifying this further, we have 2.9980001. Okay, so with these values, it seems it's quite obvious what value f of x is approaching to as x approaches 4. So we have here 2.25, 2.81, 2.9801, 2.998001, And if we're going to round this off, so it's approaching 3 actually from the left. Okay, so this time let's observe or consider the right side of 4. So let's erase everything first since we only have a limited working area. So again, let's have x here. Sorry. And f of x. So we have x squared minus 6x plus 11. So earlier I have shown that from the right we're going to choose values between, since 5 is the closest number from the right to 4, so x should be less than or equal to 5 but greater than 4. So we could have 5 so as the initial number, and then from the right going to 4. So that means we have 4.5, 4.4, 4.3, 4.2, or we could have 4.0, 4.1, 4.01, 4.001, 4.0001. So this is actually almost or close enough to 4 but not equal to 4. Okay, so let's start with 5. So when x is equal to 5, so we have 5 squared minus 6 times 5 plus 11. So we have 25 minus 30 plus 11. And 25 minus 30 is equal to negative 5 plus 11. And negative 5 plus 11 is equal to 6. So when x is equal to 5, our f of x is equal to 6. Okay, then next, let's choose another value much closer to 4 from the right. So let's erase this first. So this time let's have 4.5. So when x is equal to 4.5 squared minus 6 times 4.5 plus 11. So 4.5 squared is equal to 20.25 minus 6 times 4.5. 6 times 4.5 is 27 plus 11. So simplifying this, we have 20.25 minus 27 is equal to negative 6.75 plus 11. And negative 6.75 plus 11 is equal to 4.25. Okay, Then let's choose another value of x much closer than 4.5 to 4. And let's say we have 4.01 or 4.1. Let's have 4.01. So we have 4.01 squared minus 6 times 4.01 plus 11, and 4.01 squared is equal to 16.0801 minus 6 times 4.01 is 24.06 plus 11, and 16.0801 minus 24.06 is equal to negative 7.9799 plus 11. And simplifying further, negative 7.9799 plus 11 is equal to 3.0201. Okay, that's it. Then let's choose another number much closer to 4. This time let's have 4.001. So substitute 4.001 to all x's. So we have 4.001 squared minus 6 times 4.001 plus 11, and 4.001 squared is equal to 1.600 and 8001. Well, actually, we can round this off to 1.61. Okay, but let us use as many digits as possible. And let's continue. 6 times 4.001 is equal to 24.006 plus 11. And simplifying this, we'll have 1.6008.001 minus 24.006, and we have negative 22.4051 and 3/9 plus 11. And simplifying this further, negative 22.405199 plus 11 is it correct? I'm sorry. Again, let's check. Maybe I got it wrong. I got some mistakes along the process. So we have 4.001 squared is 16. It should be 16. I'm sorry. I said so. So it should be 16 point. So 16.008001. Okay, that's it. So 16.008001 minus 24.006 is negative 7. So this should be negative 7. Negative 7 point 99799 plus 11 plus 11, so we have 3.002001. Okay, and let's choose the last one, since earlier we have only 5, or we assigned 5 values for x. So let's have 4.0001, and I have already heard the computation. I won't show you the computation anymore, and the value actually is equal to 3.00220001. And as you can see, when we round this off, 3.0002 is approximately equal to 3. Okay, so from our table of values earlier, from the left of 4, we have 3, and f of x is equal to 2. 3.5, we have 2.25. We have 3.9, we have 2.81. 3.99 is equal to 2.9801, and we have 3.99, which is equal to 2.99801. So using the values of f reflected in these tables, we conclude that let me make some space here. That the limit of x squared minus 6x plus 11 as x approaches 4 is 3. Okay. What if we use graphical approach? Do you think we will have the same answer? The limit is 3. Well, let's find out. Okay. So, using the graphing tool GeoGebra, let me show you the graph of f of x equals x squared minus 6x plus 11. So this is the graphing tool that I'm using, the GeoGebra. Okay. Let's delete everything first. And then let's input the function. We have, sorry, we have f of x is equal to x squared minus 6x plus 11. And the graph actually looks like this one. Okay, that's it. Earlier, we sketched the graph of f of x equals x squared minus 6x plus 11 using a graphing tool, GeoGebra. And I've posted it here on our presentation to illustrate graphical approach. Okay, so in the figure, the graph of f defined by f of x equals x squared minus 6x plus 11, which is a parabola opening upwards and with vertex at 3, 2. And we can see that as the points generated using values of x becoming closer and closer to 4, the corresponding y coordinates of the points or f of x values are becoming closer and closer to 3. So recall that using tabular approach, we initially set x equals 3 from the left towards 4 and 5 on the right side towards 4, wherein when x is equal to 3, our y values is equal to 2 and approaching 3. And when x is equal to 5 from the right, our y values, or y value rather, starts at 6 and approaching 3 as well. And recall that to determine or evaluate a given function using its graph or given its graph, we only need to trace the graph immediately from the left towards 4 and immediately from the right towards 4. So that means from the left, we only need to trace the graph, the trend or the behavior of the graph from the left towards 4. Okay, and actually it's approaching this point where our x approaches, our y coordinate rather approaches 3. And from the right, if we're going to trace, trend or the behavior of the graph, we have this one approaching this point as well, where our y coordinate approaches 3. Therefore, we can say that the limit of x squared minus 6x plus 11 as x approaches 4 is 3. Okay? And it is also important to consider that the value being approached by f of x as x approaches c, in this example we have 4, either from the left or from the right of c, must agree in value for the limit to exist. So that means from the left, both from the left and from the right, they are approaching the same value. Otherwise, the limit does not exist. Okay? So this will be discussed further in the succeeding lessons. But for now, let us focus on determining the limit of a function by using tabular and graphical approaches. So that's it. On our next video, I'm going to show you on how to evaluate limit of a piecewise function using tabular and graphical approaches. So to keep yourself updated, subscribe and hit the notification bell. Thank you.